Hi students, today we will discuss about the area vector. We know area is a scalar quantity, but in some problem it has to be treated as a vector. Actually, area is scalar quantity, but when we discuss about in this chapter, this area will be treated as a vector quantity. How? Suppose this is any of the area. This is an area. So if we represent this area as a vector quantity, so what will be the direction of the area vector? Here if we draw a perpendicular, so from this area, this direction of this perpendicular, that is normally outward from the surface area, this is the direction of area vector. Here suppose here if we take one small element ds, this is one small element inside this area ds. So if we represent this small area element in vector form, then the direction of the area vector will be normally outward. So from this ds, if you draw a perpendicular and direction is outward, so this is the direction of the area vector. So here if we represent this area vector ds, suppose area vector ds, then vector ds is equal to, this is the ds, the magnitude of the vector, and suppose this area vector, the unit vector of the area vector is represented by the n cap, so ds vector is equal to ds into dot n cap. So such a way the area vector can be represented. So I repeat once more, from any area if we draw a perpendicular along which direction outward from that area, so that direction of the perpendicular drawn outward from the surface, that is the direction of the area vector. Now we will discuss about the electric flux. Electric flux means, we know about the electric field lines. Suppose this is one area, this is placed in an electric field. This is placed in an electric field E. So when this is placed in an electric field E, so there are also electric field lines. Now the electric field lines also passing through the surface area, Now suppose 5 electric field of lines passing through the surface area normally. So how many electric field of lines? 5 electric field of lines passing through this surface area normally. Then that 5 is the electric flux of this surface area in this electric field. So we can say the electric flux through a surface area means the number of electric field lines passing through the surface normally. If 5 electric field of lines are passing through surface, then 5 is the electric flux through the surface. If 10 electric field lines are passing through the surface normally, then 10 will be the electric flux. Here I draw one electric field E. So here in this electric field, any arbitrary surface area is placed in this electric field, and in this electric field, in this surface area, we take one small surface area element, that is ds. So what is the direction of the area vector? normal to the surface area. This is the direction of the area vector. So this is the ds vector, direction of the area vector. And suppose this area vector makes an angle theta with this electric field. Make an angle theta with the electric field. So for this case, what will be the electric flux? The electric flux that is equal to, here if this is E, so along this area vector the component of E will be what? E cos theta. This is the E, so E is a vector quantity, so along this ds, that means along this area vector, the component of the electric field will be what? E cos theta. So electric flux, that is E cos theta into ds. So from here you can write E ds cos theta. So E ds cos theta, here we can write here, it is in vector from E dot E vector dot ds vector. So this is the electric flux. Suppose this is defined by the d phi. So d phi is equal to E dot ds. Now here this is the E. Why take this component of E cos theta? Because if this is E, then E cos theta is towards the area vector ds. That means the E cos theta is also normal to the surface area. We know that the area vector also normal to the surface area. That means E cos theta also normal to the surface area. And electric flux means the number of electric field lines passing through the surface area normally. That's why we electric flux, we write here E cos theta ds. That means the electric field, the component of the electric field normal to the surface area into the area element. So from here we write that E dot ds.